In this lesson, we're going to go over how we can add and subtract rational expressions. Now, before we get to actual rational expressions, let's look at how you would add and subtract regular fractions. So, when we're adding or subtracting fractions, we want to make sure that we have a common denominator. So, in number one, we can see that both of these denominators are the same. So, when the denominators are the same, you can go ahead and just add the tops together. So, I would add 7 and 11 to get 18. And then I would keep that common denominator and get 16. Now, in order to simplify this, I want to look for a common factor, and both 18 and 16 have a common factor of 2. So I can divide 2 out of both of these, and I would end up with 9 over 8. Okay, in number 2, 2/3 minus 1/8, I look to see if they're the same denominator, which they are not. So if we want to get a common denominator, we need to multiply the 3 by an 8. If we multiply the bottom by 8, we have to also multiply the top by 8. And then 8 has to get multiplied by 3, again, also on the top. So now we have 16 over 24 minus 3 over 24. So now we have a common denominator, and we can go ahead and subtract the numerators. So we get 13 over 24. And that does not simplify, so we leave it as is. In number 3, again, we don't have a common denominator. So you could multiply the 9 by the 6 and the 6 by a 9 to get a 54 as a common denominator, but that's not the least common multiple, which is what we want to find. So we want to see what number we can use. If you want to use 54, that's fine, but we will have to reduce our final answer. I can make both of these denominators into an 18 by multiplying the 9 by a 2, so same thing on the top, and the 6 by a 3. So now we have 4 over 18 plus 9 over 18. We have that common denominator, so we can go ahead and add the numerators to get 13 over 18. And again, this does not simplify, so we leave it like that. So we're going to follow the same steps for adding and subtracting rational expressions as well. So we're going to start with adding. So the first thing we want to do, we're looking at number 1, it's already factored for us. So we want to follow the same steps as we did with regular fractions. So the first thing we want to do is check the denominator and see if they're the same. So in number 1, the denominators are the same. So since the denominators are the same, I can go ahead and just add the numerators. So I'm going to combine them and smush them. That's a very mathematical term. We're going to smush the tops together. So we have x plus x minus 4 over that common denominator of x plus 5, x minus 2. Now what we want to do on the top is actually combine it together. So we're going to combine our like terms. This is going to become 2x minus 4 over x plus 5, x minus 2. Once we have one fraction where the numerator is in standard form and combined together, we'll see if we can factor that numerator in order to simplify. So the 2x minus 4, I can factor that by pulling out a common factor of 2. Then I'm left with an x minus 2, and the denominator is still staying the same. So when we look at this, we can see that there is a shared common factor in the numerator and the denominator, which we can cancel out, the x minus 2's. So we're left with 2 over x plus 5. And just like what we did last class with multiplying and dividing, we do have to have a domain restrictions that go with our answer. So our actual answer is a simplified answer. Domain restrictions, we're going to go back a step to where we had that common denominator. Set that common denominator equal to 0. So x cannot equal negative 5 or positive 2. Okay. If we look at number 2, first thing we notice is that the denominators are not the same. So x plus 1, x minus 1, they are different. So think about with regular fractions. If I have a regular fraction, and I'll go back to here to reference this. Let's look at number 2. So I had a 3 and an 8 in the denominator. The only operation that we can use to get a common denominator is multiplication. So I can't just, for instance, in this case, add 5 to the 3 and make it an 8. So when I look at what I have here for number 2, what I cannot do is let's say subtract 2 on this side and make this x minus 1. That's not going to be able to be done. So we want to think in terms of multiplication. So can we turn x plus 1 into x minus 1? If you think that you can multiply by a negative, it won't be exactly the same. If we multiply this by a negative 1, we will end up with negative x minus 1, which is not the same thing as this. So again, for reference purposes, let's look at this example here for number 2. So with a 3, right, I can't make a 3 into an 8, and I can't make an 8 into a 3. So what I had to do was multiply by the other denominator. So the 3 didn't have an 8, so I had to multiply by 8. The 8 didn't have a 3, so I multiplied by 3. So this x plus 1 doesn't have an x minus 1. So we're going to multiply by x minus 1 on the bottom and then also on the top. The x minus 1 needs an x plus 1. Again, also on the top. Okay, so once we figure out that now the denominators are the same, we want to make sure that we expand the numerator. So we're going to take that 3 times x minus 1 and actually distribute that. So this is going to become 3x minus 3 over x minus 1, x plus 1, plus, and we're going to distribute the x, so x squared plus x, over x minus 1, x plus 1. Okay, so now that we have our two fractions set up and they have a common denominator, now we're going to smush the tops together. So this is going to be 3x minus 3 plus x squared plus x over x minus 1, x plus 1. So the top is now smushed. What we want to do is then go ahead and put this into standard form and combine any terms that we can. So x squared will go first. We have a 3x plus an x, so that's going to be 4x. And then we have minus 3 over that common denominator. Once we have this written in standard form, we want to look to see if we can factor the numerator. So here, if we were going to factor it, we would say what multiplies to negative 3 and adds to 4. But nothing can multiply to negative 3 and add to 4. So we cannot actually factor this. So this would be our final answer. So not every single time that we do these problems will we be able to factor and cancel things out in the top and the bottom. Okay, sometimes you can do that. Sometimes you can't factor the top, like this example. Sometimes you can factor the top, but it doesn't cancel with anything in the bottom. Okay, so just be aware, just because you get something that might not factor or might not cancel does not mean that it's necessarily wrong. Okay, and then along with this, we need our domain restrictions. So x cannot equal 1 or negative 1. So that's coming from our common denominator. Okay, and then we're going to look at this last question for adding. So here we can see that the denominators right now are not the same. So what we want to do if the denominators are not the same is factor them if we can. So in the example for number 2, we couldn't factor because x plus 1 and x minus 1 were already factored. So here, I'm just going to rewrite this. This denominator of x minus 1, we can't do anything with that, so we'll leave it as x minus 1. For the second denominator, x squared minus x, we can pull out a GCF of x, and then we're left with x minus 1. By factoring the denominators, it will make it easy to figure out what each fraction has and what each fraction is missing. So now if we compare the denominators, they're not the same, but we can see that they both have an x minus 1. So that second fraction has an x, the first fraction does not. So that means that we're going to have to multiply that first fraction by an x on the bottom and an x on the top. Okay, once we figure out what we need to multiply by, we're going to expand the top. So I'm going to rewrite this fraction by distributing the x. So this is going to be x squared plus x over x minus 1. So you want to keep the denominators factored and you want to keep the numerators unfactored, like as expanded as possible. So now we have plus the negative 2, x minus 1. So they have the same denominator, so we can go ahead and smush the tops. So x squared plus x minus 2 over x minus 1. Now that it's smushed and in standard form, that numerator, we want to see if we can factor that numerator. So what's going to multiply to -2 and add to 1? So that's going to be x plus 2 and x minus 1. And then our denominator is x minus 1. Okay, then we want to see if they share any factors on the top and the bottom. And the x minus 1s are the same, so they can factor out. And we can cancel them out. And then we're left with x plus 2 over x. And that's our final simplified answer. Now be careful, you cannot cancel out the x's because there's a plus 2 on the top as well. Since that x on the top is attached to something through addition, we can't just cancel out part of that. So this is our answer. And then our domain restrictions, we're going to get that common denominator, which was x minus 1, and set both factors to 0. So x cannot equal 0 or 1. Okay, now when we look at subtracting, subtracting is very similar to adding. It's pretty much the same process. The one thing you want to be careful of is the negative that we're using for subtraction. We want to make sure that we distribute that. So we'll talk about that more in a minute. Let's look at number 1. So first thing we notice is that the denominators are not the same. So what we want to do first is factor the denominators if we can. So the top here, x plus 3, is going to stay. This denominator, we can't factor because it's already factored. Then minus. Now, since I'm subtracting everything that comes after that subtraction sign. And I'm only going to apply this to the numerator. So when I'm subtracting, I'm not just subtracting the 6x, I'm also subtracting the -7. So the way I'm going to write this is by putting this in parentheses. 6x minus 7. So that way when I actually go to kind of smush the tops together, I know to distribute that negative to both. Now, if that's confusing, what you can do is change this minus sign here to a plus, and then change both of these signs and make this -6x plus 7. Either way is fine, just don't forget to distribute that negative. Okay, so we're going to leave that like that for now. We're going to factor this denominator. So multiplies to 2, adds to -3. We're going to use x minus 2 and x minus 1. So looking at the denominators, we can see that they both have an x minus 2, but the second fraction has an x minus 1, so that means that the first fraction needs an x minus 1. So I'm going to multiply x minus 1 and x minus 1, right, on the bottom and on the top. All right, so next thing we're going to do is we're going to FOIL this numerator here. So x times x is going to give me x squared. And then I get a 3x and a minus 1x, so that's going to be a plus 2x. And then we get -3. And then our denominator is here. Okay, then I have the minus, and I'm just going to keep the parentheses for now. So 6x minus 7 over x minus 2, x minus 1. Okay, now two things to be careful of. One, we do not want to factor the numerator. You cannot factor until you've smushed it together. Okay, if you factor the numerator, you're going to end up canceling out the x minus 1s, and you're going to get what you started with, which isn't going to help us solve this at all. Second thing you want to be careful of, or not be careful of, but notice the denominators. Okay, it doesn't matter the order they're written in. Right? If you're multiplying, the order doesn't matter. So just because they're not written the same exact way doesn't mean that they're not exactly the same denominator. Okay, so we do have the same denominator, so now we're going to go ahead and smush the top. So we have x squared plus 2x minus 3. Don't forget to distribute the negative. So this is going to be -6x, and then this becomes a positive 7. So the main mistake that everybody makes here is forgetting to distribute. If you don't distribute it and you keep it as a -7, you're going to get a completely different answer for the numerator, which will get a completely different answer for the whole problem. All right, so it's common denominator, x minus 1, x minus 2. All right, so we've smushed the top together, but now we want to make sure it's in standard form and combine like terms. So we have x squared, we have a 2x minus 6x, so that's a -4x. -3 plus 7 is positive 4. And then we have x minus 1, x minus 2 on the bottom. So now that it's one fraction, the numerators were smushed, and it was combined and put into standard form. Now we can factor the numerator. So multiplies to 4 and adds to negative 4. So we're going to use x minus 2 and x minus 2. The denominator is still x minus 1, x minus 2. Okay, and now the x minus 2's we can cancel out. Now be careful. We can't cancel the 2 that are on the same level next to each other, and we can't cancel all 3 at the same time. We can only cancel that 1 on the top, 1 on the bottom. So it doesn't matter which x minus 2 on the top we use. I'm just going to use that one and that one. So we end up with x minus 2 over x minus 1. And that's our simplified answer. And then our domain restrictions, x cannot equal 1 or 2. Okay, and then this last one, okay, again, we see that we don't have the same denominator. So what we want to do is factor if we can. So the top here is staying the same. X squared minus 2x, we're going to factor out a GCF of x. So we're left with x minus 2. And then minus. And because we're subtracting, again, I'm going to put this numerator that's next to the subtraction sign in parentheses so we don't forget to distribute that negative. 2x minus 4, we're going to pull out a GCF of 2, so we're left with x minus 2. So when we look at these, we can see that they share an x minus 2. The first fraction has an x. The second fraction does not, so we need an x over here, top and bottom. And then the second fraction has a 2, and the first fraction does not, so we need a 2 on the bottom and on the top. So now what we're going to do is distribute the top. So our first fraction is now going to become 2x plus 4 over 2x, x minus 2. Okay, and remember, we cannot cancel the 2x's. Okay, we don't want to do any canceling until we've smushed the tops together. And even if it was smushed, you still can't cancel out the 2x's because this top one is attached through addition. All right, so then I have minus, and I'm going to put parentheses again. I'm going to distribute the x. So x times x, we get x squared, and then plus 2x. And then our denominator is 2x, x minus 2. All right, so now the denominators are the same. So what we're going to do is smush the tops. 2x plus 4. Don't forget to distribute the negative. So negative x squared minus 2x over 2x, x minus 2. All right, so now that we've smushed the tops and we have one fraction, we want to make sure that the top is in standard form and like terms are combined. So standard form means I have to put the x squared first. So I have negative x squared, 2x minus 2x will cancel out, and now I have plus 4 over 2x, x minus 2. So now that it's smushed into one fraction and the top is in standard form and combined like terms, we want to see if we can factor the numerator. So the first thing we want to do is always look for a GCF when we're factoring. So your x squared term should always be a positive. If your x squared term is a negative, that means it has a GCF of negative 1. So the first thing we'll do is pull out that negative as the GCF, and then we're left with x squared minus 4. And then we have 2x again, x minus 2. So after we've factored out the negative from the numerator, we still have a quadratic. So when we see a quadratic, you want to see if it can factor further. So we're going to factor that using difference of squares. So that's going to become x plus 2 and x minus 2. And then we have this 2x, x minus 2. So they have an x minus 2 on the top and bottom that we can cancel out. So our final answer would be a negative x plus 2 over 2x. If you want, you can distribute that negative to make it negative x minus 2, but you don't need to. And then our common denominators we're going to set to 0. So that's going to be our restrictions where x cannot be 0 or 2.